Good morning, everybody. After disappointing Viking showing, now we can forget that and move on. So I told you I reached out to the tech cert office to see if we can review the exam questions, and they did respond and say their policy and procedure is not to do that for exams, just for exam security. And so I know, I mean, there's nothing from keeping anybody from taking a picture of the exams and, you know, whatever, but at any rate. Yeah, so they did say once everybody finishes, which as of yesterday, there's still 3 to take the exams, they will provide me, like they always do, with a listing of which questions were the most difficult for people. And so if provided that happens prior to the end of the class, I can use that information and go back through and say, okay, you know, maybe not the exact question, but I can say here's the concept that that was a little more difficult for folks. So, at any rate, once everybody finishes, I will look at the questions and get that. But anyway, I just wanted to let you know I did reach out to the tech cert office, and that was the response. But before we get going with today, any questions about what we did yesterday or anything else? Okay, well today we're going to talk about a bunch of different things, barriers, wearing courses, and then other things, I think utilities or something. And with us for the first presentation is Pratik Patel. He is the Metro Region Bridge Construction Engineer. It's a position I had for about 13 years. It's a great position. And Pratik, you've been in there for like a year?
Actually, maybe since September, so like 4 or 5
Oh, okay, 4 or 5 months, so it's not even a year.
Yeah.
Okay. But at any rate, he's the Metro Region Bridge Engineer, and is going to be taking us through the barriers and railings and things like that. So you got that turned on? Let me just check the volume. Okay. I'll check this. Turn it down for. Okay. So with that, Pratik.
Okay.
Yeah, it's on. Start and then I'll get back. Yeah, just talk a little louder right at the start.
Okay. Sounds good. Yeah, until the mic gets a battery, I'll just try to talk loud. But I've been told I'm not a loud talker, so. Hopefully, y'all are too upset about the Vikings, but I'm a Lions fan, so I don't feel too bad.
You said you were an LA fan. That was fun.
So, presentation's about barriers, sidewalks, and medians. So, which is session 13. Basically, any of the concrete that's placed on top of the deck. So let's, I guess, go over the terminology here. So these used to be called railings, but I think the proper terminology is barrier. So barriers are solid and made of concrete. Railings have openings and usually made of metal. So generally these definitions are true, but there are still some exceptions, like with historical bridges. I think, yeah, there's still some metal barriers out there, and there are some concrete barriers with openings on them that are still in service today. So yeah, the main difference is the barriers are solid, railings have openings, and they're usually made of metal.
Testing. Does this work? Good? Okay. Sounds good. Okay, so the primary purpose of the barrier is to provide separation with traffic. And in general, the primary purpose of the railing is to provide pedestrian safety. So this picture here shows an example of the function of both of those things. So on this one, we have a barrier separating traffic from running into pedestrians or vice versa. You know, hopefully try to keep pedestrians from running into traffic, but you never know. And the railings here keep the pedestrians or bicyclists from falling off the bridge, hopefully. So yeah, here's a little video about how barriers do matter. So you know, maybe of all the bridge construction items, barriers aren't really that interesting to talk about because they're usually don't have too many questions or confusions when building them. And they, I don't know, they really aren't super interesting to construct either. So, but hopefully this video plays. You know, they do serve a purpose. So I believe that video was from Wisconsin, but over in Minnesota, there's similar incidents as well, where here's a picture of pickup truck almost went up the Cedar Avenue Bridge. Yeah, and I guess a common theme between the two incidents here is you can see the snow being piled up against the barrier, kind of in a way making like a little ramp type thing. So, you know, we've been trying to, I think over the years, barrier height has been going up a little bit slightly too. But, you know, this is, I guess, more of a reminder that the concrete barrier shape that matches the plan is important as well. So here's another example of, I think this was in summer of 2022, video.
Wow.
That escalated rapidly.
Fire down there. See where you go.
Yeah, so this was I believe this was on the ramp of Highway 10.
Driver, get out of there?
Yeah, door opened up.
Oh, there you
Yes, as far as I know, I think everybody walked away from this incident, even though it looks pretty bad. But yeah, you can see the truck smash into the barrier.
Oh, and the cardboard.
Yeah. But you know, on this one, you can see like the barrier served its purpose there, right? No snow on here to create that kind of ramp. So, hopefully those examples kind of give you a little bit of an idea of why you should care about barriers. So, you know, one of the main things is safety, obviously saving lives. As you saw in that video before, like the barrier didn't do its job, you know, who knows what would have happened if the truck, you know, went over. So yeah, they help direct and, you know, keep traffic on bridges and in the direction they should be traveling. Basically, their purpose is to keep vehicles and the people in them on the bridge and not, you know, not go over. Lots of agencies, including MnDOT, you know, they spend millions of dollars crash testing barriers, make sure that they're tall enough to keep large vehicles from crashing through, and redirecting the vehicles back onto the bridge. And yeah, the focus is to make sure that they're strong enough to make sure vehicles don't crash right through the barriers. So, you know, safety, stability, geometry and shape of the barrier plays a big part, and the barrier strength is important. So from crash testing, we learned that single slope on the barrier is the safest design to keep vehicles from launching or snagging when traveling at high speeds. On the left is the old F-shaped barrier, and on the right is the type S barrier. So you could see the straight base of the barrier. So this shape is for the high-speed roadways and exhibit more consistent crash performance through the testing than any of the other previous shapes. A lot of these pictures in the presentation are also from the previous shape F barriers, so keep that in mind as we go through the presentation. You know, but now, you know, bridge plans have pretty much all been updated to include the S barrier. You might see some F barriers if there's like transition, you know, creating a transition from the old type to the new type. Because you can't have like, you can't immediately go from, like if you're connecting to an old barrier, you can't immediately go from like an old, abruptly go from a type F to a type S, because then you create a snagging hazard due to the difference. So you might see like the transition during construction as well, if you're connecting into an old one. So yeah, all barriers require crash testing and have to meet certain crash or test levels to be able to be used. Bridge railings in these crash tests must prevent the vehicle from going through the railing, prevent barrier debris from entering the vehicle, smoothly redirect the vehicles, prevent it from rolling over, and ensure that the impact of passengers from the crash is low too. So I think this is a video as well, if it plays. Maybe not. Well, that was supposed to be a fun video of testing, but I guess it's not. I don't know, it is. Yeah, so you can see how the barrier does its job. It redirects the vehicle, prevents the vehicle from going over, and it also, you know, doesn't significantly, you know, tries to not harm the driver as well. So, you know, that's the goal, is try to, you know, try to save everything as much as you can. So another video, you can see the profile of this barrier. The slope of the barrier will actually cause this vehicle to ride up the barrier. Yeah, so like, you know, with the older shape back when they crash tested these, they considered riding up the barrier like that positive, because it dissipates some of the energy from the hit. But obviously could lead to rollovers and stuff. So now we've opted mostly for the single slope, for the new single slope barriers now, so. Yeah, so we meet the safety requirements and save lives by making sure that the barriers are constructed to meet stability, geometry and shape, and barrier strength requirements. So stability is referring to the stability of the vehicle under impact. basically like, you know, like you saw in some of the videos, like how can you try to minimize the impact of the barrier, like make sure the vehicle doesn't flip over or anything. And geometry is referring to the shape of the system. Try to prevent like rolling over and stuff. Barriers are also important for drainage and snow. You saw in a couple of the videos how the snow can kind of create like a little ramp too if it's piled up too much. So yeah, making sure that like rain and runoff is directed off of the bridge along the gutter line, keeping it from pouring off the edge down underneath the bridge onto traffic or whatever's down there. And it also leads to the deterioration of the edge of the deck, just due to the, if it's, you know, the salty snow runoff. You know, snow plows also use barriers as a guide for plowing, and it can be helpful to stop snow from going off the bridge and onto the traffic below too during plowing. And, you know, aesthetics is important too, even though it's not necessarily a safety or strength concern. A well-constructed barrier is important to the traveling public, and, you know, making sure it looks safe to people is also important. So, you know, in this section, we'll go over an overview of the key points of barrier construction, spotlight of looking to where to look in the spec book to make sure that your work meets spec. 4 main topics that we'll go over is concrete placement, finishing of the barriers and aesthetics, metal railings, and any miscellaneous topics that don't fit into any of the previous categories. So, concrete placement, to ensure that we meet stability, shape, and strength of barriers, following the standard specs and the special provisions for concrete placement is important. If you look on it's page 352 there of your spec book, there's a couple pages there that are pretty important for the concrete. Probably some of the most used and most important for concrete bridge construction. Usually we recommend putting like a little post-it note in that section, because for concrete you'll be referring to that a lot. One of the more important pieces of information in there is on the bottom, I think on the bottom of page 353, it says clean set concrete of loose material and dirt before placing fresh concrete against it. That's important. Make sure you have a clean surface for the new concrete to go on. One other important note is after pouring the bridge deck, you may be required to put a curing agent on the bridge deck. Proper care needs to be made to make sure protect any rebar that sticks out of the deck if you want to hook concrete to it. It's almost impossible to remove this cure off the rebar if it's left in place. It creates a bond breaker between the rebar and the new concrete you pour. So you want to make sure you get a good amount of cure, but don't want it to drift from the area where you're applying the cure. So yeah, in this picture, the barrier dowels should have been covered with wet burlap before spraying the cure. So that's good lesson to make note of. Yeah, basically the concrete barrier shouldn't be placed without authorization from the engineer until deck false work has been removed or loosened and after an acceptable bridge slab cure has been obtained. Yeah, so the contractor can choose to do two forms of construction for barriers. Hand form construction or slip form construction. For slip form barrier placement, this is like a, like a mold, like a Play-Doh type mold where you just, where you have an extrusion machine. Make sure they bring out the correct shape if you're using the mold. When slip forming the barriers, we have to be sure that the concrete has less than 1.25 inches of slump. Concrete with slumps greater than that will be rejected. This helps maintain the uniform line and grade of the barrier. With consistent slump, the cement finisher will obtain a uniform texture through the pour too. And this information can be found in the spec book too, as well as the concrete mix. So with slip form barriers, before they pour the barrier, the contractor has to dry run the anticipated pour and check clear distance from the slip form template to the reinforcement. The contractor also has to make the control joints by installing rigid plastic inserts, as well as conventionally hand form the ends for 4 feet on either side of the joint. At the ends of the slip forming or where the guardrail anchor plate is located. And most importantly, they have to get the wet cure in place within 30 minutes. I believe the department will, monetarily deduct money for every 5 minutes period of portion after that. Regarding wet cure, special surface finish is considered a curing compound as per table 2401.3-3. I believe this is on page 373 of the spec book. You'll see that the concrete barriers, parapets, and end posts on there, a special surface finish is required. AMS curing compound is not an acceptable curing compound, and that the special surface finish 2 is an acceptable method of cure. Here we have an example of a hand forming while slip forming a barrier. There is a lighting conduit cast in it, so if we have a light blister that is different than shape than the Muno, they would have to slip form over this section. So this short section here will be hand formed after the rest of the barrier is slip formed. Another picture here, you'll want to make sure that they have at least 2 inches of clear distance from their reinforcement on the front face. Check the plans too. Some plans have even 3 inches of cover. This clearance is important because you want to try to keep the salt away from the rebar as best as we can. And if slip forming the barrier, the contractor needs to install additional reinforcement these little bars to make sure that the machine doesn't pull the cage along with the form. Yeah, so, yeah, this one's an old picture, so the longitudinal reinforcement is tied continuously now. You don't have these gaps. So it creates a weak point in the barrier, and we don't want that. So here's an example of something that we think is a result of the shifting slip form, and it pulled the rebar to lap over the bridge joint. It's just, we aren't 100% sure of what caused this, but that's something we suspect, so just making sure that the slip forming isn't pulling the rebar is important. If the contractor can't slip form the barrier and they have to hand form the barrier, the form shall be either metal, wood, or suitable material capable of sustaining the concrete in the proper position until the concrete is set. It shouldn't move when you start pouring wet concrete. And then the forms must be conformed to the required shape and design. Yeah, the placement of the concrete shall be controlled to prevent segregation. As they pour the concrete in a form, there's only a small opening at the top of the barrier, and there's all sorts of bracing. The rocks will want to segregate out of it, so it needs to be vibrated to fill all the voids, and struck off to finish the elevation and create that smooth finish. Make sure the contractor does not over-vibrate the concrete. Over-vibration will cause segregation, in which the cement and sand could travel to the surface, leaving a weak surface that weakens the barrier. Yeah, keep the when we're pouring these cast-in-place barriers, we're going to keep the shape of the forms that were constructed and signed off on. So, concrete weighs a lot, so it has a tendency to blow or widen out its forms if you don't have these bottom oilers. So make sure the contractor has the snap ties and rods to the correct dimension to keep the form from moving while pouring. So yeah, it's important to keep the form from moving. Here we also have these cross ties to keep it lined up. So here's something that, if you don't have enough bracing on the wood forms, it doesn't meet our minimum surface tolerance of a 1/4 inch of deviation within 10 feet of length of barrier. And any hardware that is installed on the barrier, make sure that it's non-corrosive hardware. Where a guardrail is installed, they can't slip form these sections, so it will always be hand formed. And make sure that nothing there can rust or deteriorate over time. And make sure to check the barriers and railing details in your plan set to ensure that the contractor is installing the right guardrail anchor plate and that it's being installed correctly per the plans. Here we have a cover plate located at the expansion joint. Make sure that they build this into their forms prior to pouring the concrete, and make sure that these anchors for the cover plates are well embedded in the concrete. A relatively recent change in the, for barriers is that all 4 bottom longitudinal bars are now, they're number 6 bars, they used to be number 4 bars. And there's also a designer note now that limits the length of all barrier longitudinal bars to 40 feet. It was in the design manual, but the note adds some clarification because some people are putting longer, or stipulating longer bars in their plans. Further, for removal, we have to require that the forms stay on for at least 12 hours. Now we just state that the barrier forms may be removed when the concrete is self-supporting and retains its molded shape, instead of putting like a minimum time period on this. And yeah, you'll also see a table in the specs for curing requirements. So you can see, like, for barriers and parapets, the minimum strength required to pull the form is when the concrete is self-supporting. So there's no. So we do have a maximum time frame, though, that forms must be removed within 12 hours. So, after the forms are removed, the contractor is to round the edges to the radius shown in the plans. Even after the 12 hours, the concrete is still somewhat, workable when they remove the forms. Yeah, it's still somewhat workable, but after the 12-hour point, it gets tougher. But main thing is before removing the forms, make sure the concrete is self-supporting. And according to the special provisions for special surface finish of concrete surfaces, the contractor is to remove the forms as soon as the concrete can retain its molded shape, and in no case shall the elapsed time between concrete placement and initial surface finishing exceed 12 hours. So yeah, everything I mentioned is noted in the special provisions. So after that, here are the barriers getting groomed after the slip form from finishing. They'll go along and measure beforehand or during their dry run and spray paint on the deck each place where the rigid plastic inserts for the control joints have to go. Here they're finishing the bottom edge. Note that line mark there, that's what I was talking about with the control joint location. So yeah, for control joints, they're specified on the plans. This newer control joint has been used for, I think, since 2014. So now we have a continuous reinforcement along the barrier with control joints instead of cork joints. Yeah, so you can see like the old reinforcement where it was cut off, but as I mentioned before, that creates a weak point. We don't do that anymore. So like at the end of the bridge, the last few feet of the barrier, the dowels are spaced much closer together. And then, Yeah, and that's because, yeah, at the end, that's where we want to strengthen the barrier the most. For slip form barriers, they're using plastic inserts for control joints. Popular ones are the zip strips and the speedy joint. They're both on the approved product list currently. Just look under the crack and joint materials products, and then look for the rigid plastic extrusion. So here's a quick demonstration of the process after a slip form barrier. Hopefully this plays. So they use they saw cut the relief of about 1.25 inches into there, and then they put in the plastic control joint. And then they finish the surface, like it's, kind of hidden away now. So for people looking at it, it's not even, there as far as they're concerned. Yeah, so this is a relatively new barrier install. So you can see where, you can't really see where the plastic insert was installed, except you see a little hairline crack there. But we can tell by the shape of the crack that it's a straight line crack, and that's what we wanted. That's why that's where we wanted it to crack at the joint. Compared to other when there isn't that control joint, not as straight. We want to avoid that. Yeah. So one thing is, don't install control joints next to anchorages, because now the anchorage has less cover due to the location of the plastic control joint. There's more of a risk of failure. Bridge plan details the spacing where the control joint should be installed, with spacings of less than 10 feet between each control joint. You'll notice that according to the plan, none of the control joints are located at the same location as the anchorages for the railings. So, this sheet is actually for the previous picture we saw. So clearly somebody deviated from the plans and put the control joints where the anchorages were. So it's just something to pay attention to. Yeah, so it's important to review the barrier sheets for details like that. For integral or semi-integral abutments, there's a saw cut in the joint in the deck between the bridge and the approach panel, which I'll get into later because there's an update for that, but you need to make sure that this is also include the saw cut gap in the barrier at the same location. So the 10-foot max spacing doesn't start at the end of the barrier, it starts at that joint. So yeah, this is what happens when the joint doesn't line up. Then, all these offsets, they cause cracking, and it's no fun for anyone. Here's another example. This concrete is going to crack here, so our goal is controlling the cracks and putting the cracks where we want them, which is why we want those plastic inserts, so it's a more controlled crack that's straight. You know, one last thing to look for regarding these cuts is timing. Here's an example of the brand new barrier transition. The old barrier had a substandard end post, and you know, part of the new approach panel, the barrier, you know, I think on this one the bridge plans called for a 1/4 inch wide saw cut through the entire barrier width and height, and this, you know, this shows that they just cut it partial depth and only on the front and top faces. So you know, pay attention to details like that in the plans. Barriers need to be properly cured for at least 72 hours, and you need needs to be a wet cure, so you need a surface moist condition during the cure, and then protect the barrier against vibration, shock, freezing, and you know, premature loading. The contractor can't subject concrete barriers to loading until it's at least at 45% of its anticipated strength. You know, don't allow heavy equipment on the deck. You want to load until it's, you know, barriers cured, and barrier concrete needs to have reached 4,000 psi prior to opening to traffic. So in this picture, you'll notice that there's some holes in this plastic cover, which, you know, and it needs to have that 72-hour minimum of wet cure or it will crack. So, you know, pay attention to stuff like, you know, holes in the cover and stuff, because you need that wet cure. So next section we'll touch on is the finishing and aesthetics of the concrete. Probably speed things up here because I think I've got to keep on schedule here. For, you know, all barriers get at least some sort of a finish. They may not always get what we call the special surface finish. But barriers that are conventionally formed will always get at least an ordinary surface finish, and then typically they will also get a special surface finish. I think in one of your handouts there's this flow chart that'll help for special surface finish, which you can look at. You know, historic bridges, they have their own sets of requirements. So, you know, pay attention to the special surface finishes for historic bridges. Ordinary surface finishes, they can be found in your spec book. For these forms be stripped and the green concrete be rubbed out immediately, but if they can't get the forms off without destroying the form concrete, then they have no choice, obviously, but to leave the form on. If the contractor slip forms the barrier, it's a lot faster, and they can do about a few thousand feet in a day if everything is set up. Again, the ordinary surface finish will start immediately after removal of the forms and carried on to completion. We're kind of getting away from the special surface finish 1 and moving towards special surface finish 2. So they have different, you know, I think they have some products like the text code, or that's because and there's very limited products like that, so it's because it gives us a lot more chloride resistance than other products. I think we're trying other products, but nothing, as far as I know, nothing's come of it at this time. There's still some projects out there that might specify the special surface finish 1, but really not much anymore. Maybe if it's a historic bridge with like unique color requirements, but special surface finish 2 is what's mainly used. You know, don't mix different compounds, you know, always use the same brand components. And make sure that it's applied uniformly. And yeah, all surface finish that require the special surface finish must be sandblasted or water blasted before application of the ordinary surface finish. You know, I think power grinding is also allowed to. I think the latest specs use this gray modified, depending on the corridor. Certain projects attempts to match colors used in the same corridor. Just make sure that, you know, just check your special provisions. You know, one last thing is if you see something and it looks odd, just don't be afraid to question, you know, question things. Like if you see this, you know, maybe don't be afraid to ask, like, should the pier cap or columns also be painted as well? You know, and then for the, you know, aesthetics, for pedestrian crossings on the bridge, you know, fencing is important. There's, yeah, some, I think this one is the, like, normally we wouldn't go to like these lengths for aesthetics on bridges, but, you know, for special cases, there's requirements. The chain link fence can be galvanized or vinyl covered galvanized chain link. And again, check the specs if they want anything different. You know, different cities use different types of ornamental railings. Some are historic too. So just like, you know, like I said, keep on checking the specs, right? You know, here's an example of a ornamental railing. A lot of times they'll go into like corridors and like have like the same aesthetic detail for the entire corridor. I think this one in particular is for the I-94 corridor in St. Paul. So, you know, they're usually, if you're on like a corridor, they're usually all going to be the same. So if something looks weird, bring it up. Yeah, the next section I'll go through is the metal railings. You know, I think this happened a few winters ago. A high-speed chase, stolen vehicle. Came in way too fast, crashed through the railing, and actually went over the barrier. You know, just another reminder that, you know, what you do is important. So, you know, like on here, yeah, barriers. You know, even though it came at the wrong direction, it slowed it down enough, kind of to. Yeah, so I guess the lesson here is metal railings are not intended to keep vehicles on the bridge. They're designed to keep pedestrians and bicyclists only, not, is not gonna stop a car. So that's the John D. barrier. So, you know, yeah, there's I think this particular story was the result of a crash involving 4 vehicles. Driver hit a stalled car, crossed the center line, and then plowed into a semi, and then the semi went over the edge of the deck. This is the Clark Memorial Bridge in Kentucky. So yeah, I don't know if you noticed something on this bridge, right? It's just the metal railing and not the barrier, right? So remember what I said about the metal railing that is not intended to keep vehicles from going over the bridge. So yeah, the main takeaway is barrier keeps cars and vehicles on the bridge, and then metal railings is for pedestrian and bicyclists. Yeah, so these are the specs, you know, for, you know, steel bridge construction, structure renovation, structural metals, gray iron castings for your barriers. You know, all the materials must conform to plan details. You know, make sure that they're galvanized. You know, if the spec says to galvanize them, that they are. Check the paperwork. Basically, is the lesson here. Check the specs. Make sure there's nothing else. Yeah, make sure that the shop drawings also have been reviewed and signed off by the bridge office, because some of these things can be picked up in shop drawing review too. So, you know, hopefully it doesn't get to the point where you're out there constructing and you notice something. Yeah, in the special provisions, you'll find info for the anchorages too, for metal railings. You know, as for the anchors, use cast in place type anchors unless otherwise specified in the plan. Typical size is 3/4 inch diameter bolts, and that needs to be torqued to 80 pounds, you know, unless the manufacturer specifies something else. Again, all these things can be found in the special provisions. Post-installed anchorages, they're indicated in special provisions as well. They'll, you know, just look in the special provision. They'll give you all the location and testing frequency. It's up to the contractor to determine which method that they want to use. If they want to do testing beforehand on a limited number and after starting have fewer tests, or if they want to come in after the job is done and test a lot more than. We have, you know, requirements for documentation of the installation of the post-installed anchorages. You know, those installing the anchorages, the people installing it must be certified. You know, it's a big deal because we've had some T1 barriers fail on us. So, you know, make sure whoever's installing it has to be certified. For post-installed anchors, make sure you install in sound concrete to a depth equal to the minimum depth shown in the plans or as specified by the manufacturer, whichever one's greater. And then, you know, concrete adhesive anchors, they must be on the approved products list if they want to be used. Yeah, and then meet the following conditions for installation and testing. Allow, you know, the concrete is greater than 14 days old, you know, surface is free of water prior to drilling, the hole is dry, and then any additional requirements listed in the manufacturer's installation instructions. Here's a cast-in detail or post-installed detail. Contractor has to be careful if they do the cast-in because we really don't give them a lot of space to get it correct. If they're off by a 1/4 inch each time on a 10-foot rail, all of a sudden it doesn't fit. So most of the time the contractor chooses the post-installed installation. So always check the approved products list to make sure approved products are being used, no matter what the contractor says, just make sure that it's on the approved list. Some stuff may not be on the list anymore that was previously on the list, so make sure you always check the approved products list. You know, here's some examples of cutting off anchor rods and pull-out testing. That some contractors don't drill the hole deep enough because they're running the rebar, and they can't drill through it, so they don't want to get a core drill out and do it, so they'll just cut the bolt off. But when they do that, that means the anchor will probably fail. So they should core out the hole out if they run into rebar. Yeah, here's another example of a failure here. Here's someone performing and test, you know, again, make sure that they're certified. We require that they're certified if they're doing the testing. Make sure that the testing device is set up that no portion of the device bears directly on the barrier, so the concrete's, you know, on the concrete surface, and then, yeah, within a distance equal to 1.5 times the anchor embedment depth. So, yeah, main thing, use a certified tester, get documentation, make sure it's a signed report. Just, you know, both the installer and the tester must be certified, you know, check their cards, credentials, everything. Yeah, this one is for caulking underneath the base of railings. Well, you know, we want to keep the base completely watertight, so make sure all the void space is filled. So we don't want water getting in there. As for what type of coating the metal railings get, check the special provision for 2475. That'll go through all that. So if powder coated on the metal railing is damaged, there's 2 different types of repairs. We have the type 1, which classifies damage as any type of abrasion that causes a surface imperfection. This can be repaired on site or in shop. Type 2 is a little more severe, as that exposes the steel surface larger than 1 square inch. You know, this one requires these repairs must be made at the actual shop. You know, and plans will show the control joint locations and the concrete. You know, they'll also show the barrier height in this details too. If they put the wearing course on first, we still need that height. So if it's 3'8" barrier, that 3'8" needs to be on top of the wearing course. Miscellaneous topics wrap up here. You know, metal. Oops, yeah. I think one thing for the railing is they have to be grounded for all metal railings and fences, so keep that in mind. Now I can get the miscellaneous topics. You know, we had some complaints about barrier cracks at the end of the bridge. Cracks are supposed to occur at the control joint, but these control joints are either not getting cut soon enough or not being formed right, so then you kind of get these, you know, cracks. So once again, make sure that the control joints are getting cut in a timely manner and they're formed right. This is a new thing that'll show up in the Part 2 manual in spring 2025. So remember earlier I talked about the integral or semi-integral abutments, the saw cut that needs to be made. So the barriers are slip formed continuously, and like issues of cracking have been occurring if the saw cut is not made within 18 hours of placement. So this detail will be, you know, in the manual this spring that's going to specify specifically that saw cut for integral and semi-integral abutments needs to be made within 18 hours of concrete placement. So that's a new item for this year. Some, you know, new-ish from a few years ago stuff for median construction. You know, check 2401 for the deck, you know, deck surface finish under the barrier. Yeah, plans will have the median construction stuff too. The roughed area over here is where the blue dashed line is on the screen here. You know, same thing underneath the barriers. Blue dashed line represents the areas where the structural slab that have roughened where the surface where the deck was poured. Another thing, mechanical couplers are not allowed in barriers. Keep that in mind. We do not have any mechanical couplers on approved product lists, and this is why. This is what happens when the couplers are not fully epoxied. I think if they want to do, I think we have a list of guidance on what to do if a contractor wants to do, if they want to use mechanical couplers. But yeah, you can contact your regional bridge construction engineer. For Metro, that's me, and then there's a North region and a South region one as well. Barrier tolerances. This will be used when there's a tipped barrier rather than there's a, super elevated barrier. And notice it says the word plumb. When the vertical axis of the barrier, when that's placed perpendicular to the road cross slope, the placement tolerance for the vertical axis shall be placed within 0 degrees to -2 degrees as shown in this figure. So when you have the super elevated cross sections, keep those tolerances in mind. Precast barriers generally are only used on construction jobs where they're doing stage construction, cast at the yard, and then haul for the job. All authorized repairs on those must be made before the unit is stamped, and no unit shall be delivered without the official stamp of approval. Yeah, there's a stamp there.
How bad do those have to be before you take them out of service? I think it's pretty bad.
That I'm not sure what the exact requirement is, but yeah, there's some bad ones out there. Yeah, here's a portable barriers standard plan detail. Various methods are used to anchor this barrier down, and depending on what you're anchoring to, a lot of the times it depends on if you're anchoring to the old bridge deck or the new bridge deck. If you're anchoring it into an old bridge deck, you could drill a hole all the way through the deck and put your bolt through as shown here. Yeah, you'll notice the note that says don't do this for new bridge decks. I think on the new ones you can drill part way through. So bridge nameplates, I think we actually don't install benchmark discs anymore, but bridge nameplates are usually on the front of the plans. They always line, so they always line joints in the concrete up. They need to be continuously, and they need to be cut to provide a weakened plane for that, limit the number of cracks. So you see how the joints aren't lined up in the picture? They should be lined up to minimize cracking. This is a nameplate detail. Make sure the nameplate is on site prior to then slip forming the barrier. Locations on the plan, make sure they don't put it upside down,
Probably looks great when it's looking down the corner.
Yeah, maybe. Yeah, this is just caused problems, so they have to be chipped out and reset. So, okay, so I think this is my first time presenting, so I'm not sure. Do you guys have something to answer these questions, or is it just kind of we'll just say, okay? Sure. Okay, so I'll ask the question here. Try to at least make sure you guys paid attention a little bit, right? True or false, in no case shall the elapsed time between concrete placement and the barrier forms and completion of surface finishing exceed 12 hours. Yep. Next one, true or false, concrete barriers shall at a minimum receive an ordinary surface finish as specified in 2401.3 unless indicated otherwise. This one is true. So this one, true or false, all surface cavities produced by form ties and unexposed surfaces. Any surface cavities with a diameter of approximately 1/8 inch and larger and smaller surface cavities so closely spaced as to be conspicuous shall be thoroughly cleaned, saturated with water, and filled with mortar. Yep, false, you need 3/8 inches. True or false, barrier forms can be removed when barrier has attained 45% of its anticipated strength. Yep, false, when the concrete is self-supporting. True or false, slip forming of the barrier is permissible per the specifications. Easy one since we talked a lot about slip forming, right? So and slip forming barriers, it is important that the air temperature of the concrete remain constant. Yep. This one we want the slump consistency. Does anybody remember what it was? 1/4 inch. Yep, 1/4 inch. True or false, membrane curing compound, AMS, is not permitted on the barrier surfaces. Yep, we do not permit that. True or false, when installing adhesive anchors, concrete must be greater than 7 days old. It's false, it should be 14 days.
Well, 14 is greater than 7. The way it's worded.
I guess so, I can change that. Barrier concrete shall not be subject to loading until the engineer has determined that the concrete has attained a strength that is not less than 100% of its anticipated compressive strength. Yeah, false. Once it's reached 45%. The 4,000 psi. That's for traffic. Yeah. And yeah, I think it's the last one here. All surfaces to receive special surface finish must be sandblasted or surface ground before application of ordinary surface finish. Yep, that's true. Yeah, I don't think I have too much time here, but if anybody has any questions, I can try to answer.
So on barrier, the syrups, you know, on the end, that are on the approach panel,
Yeah,
has anyone considered changing how long they are, percentage projection, and still have something to tie them onto? Because typically there's in the middle, the tail is in the middle, in between the two mats of rebar in the approach panel.
right.
I mean, there's certain times because there's nothing above there to tie it into. So it's really difficult to hang those in the air.
Yeah, that's a good question. I'm not sure, because yeah, like you said, there's not much to tie into, but we do want the tighter stirrup spacing at the end for the,
Yeah, I mean, they only have
for
to
the
go
crashing,
like,
right?
3 or 4 inches longer to get that tail to rest on the bottom mat of the
Yes.
approach panel.
Right.
It sure would be nice if that was coordinated. I realize the approach panel is roadway, even though we never have an approach panel unless there's a bridge.
Mm-hmm.
But it would be nice if it would have, because that gets to be really difficult. And it's really tight spacing when you sit down there where the guardrail attachment is, and, you know, at the end, it's just hard to get everything right when you don't have anything to support it.
Anything to tie it on to? Yeah. Yeah, I can bring that up with the specs people.
Yeah, you can bring it up, but bring it up tomorrow too, Linda. We have approach panel as a session tomorrow, and I think the person that's giving it is one of the guys that works in that unit, so good question.
Okay.
Okay. Thank you.
Any other questions?
Unless anybody has anything else.
Okay, let's take a little 5-minute break, 26 after, and I have a short presentation, then we take a longer break. Thanks. You got a good part of law enforcement?
He was just, I came in late on my scrub class.